In this question, it is given that a metal sphere is hung by a string fixed to the wall. The sphere is pushed away from the wall by a stick. The force acting on the sphere, as shown in second diagram, which of the following statement is wrong? So according to the given diagram, first of all, we can just identify what are the forces acting on this object. One is nothing but weight of this object, mg, is acting in downward direction, which is mentioned in question as w, and there will be some tension developed inside the string. Let's say that is equal to T, and the string is the other external force P is acting along this direction. So these are the forces acting on it. So if you are just drawing the equilibrium condition, so there is a force P is acting along this direction. There is a tension T is acting along this direction, which is making an angle theta with respect to the vertical. And weight of this object W is acting along this direction. Now, as we know that if the object is in equilibrium, the net force acting on this object should be equal to 0. That means the value of T vector plus P vector plus W vector should be equal to 0. And second thing, we can say that, so according to the so you can just observe this second option, that is T vector plus P vector plus W is equal to 0. So second option is correct. Now we can observe that this T vector can be written as minus of P vector plus W vector. I'm just taking this P vector and W vector towards right side. So it is minus P minus W, which can be written as minus of P vector plus W vector. Now you can observe that from the diagram, this P vector and W vector are making an angle 90 degree. So if you are just going for the magnitude of their resultant, we know that the magnitude of resultant of P vector and W vector is going to be under root of P square plus W square. So we can write as the magnitude of this T vector should be equal to magnitude of P vector plus W vector. So if I'm just equating their magnitude, so what we'll get is magnitude of T should be equal to magnitude of vector sum of P vector plus W vector is nothing but under root of P square plus W square. So if I'm squaring on both the sides, we'll get as it is T square is equal to P square plus W square. Got it? So this is given in the third option. So we can say that third option is also correct. Now, again from this diagram, suppose if I'm resolving this T into its components. So what is the component of T along this direction? This is going to be nothing but T cos theta, and this component we know that this is equal to T sin theta. So we can write the value of T sin theta is equal to nothing but P, and the value of T cos theta is equal to nothing but W. Now if you are going for equation number 1, by equation number 2, we can say that tan theta is equal to P divided by W. Now you can observe that the first option, which is given in this format, that is P by W is equal to tan theta, or you can write P is equal to W tan theta. So we can say that this first option is also correct. Now in the D option, it is given that T is equal to P plus W, means magnitude of T is equal to P plus W. We know that the T vector, so actual it should be something like this, that is T vector should be equal to minus of P vector plus W vector, and we cannot say that just the magnitude of T is equal to magnitude of P plus magnitude of W. So D option is wrong, the other options are correct.